Okay, now let's look at question number 14, part B, application part of differentiation. So we are given a rectangle where the diagonal length is capital L. They want to build a fence along this diagonal. So the length of that diagonal is said to be capital L, and the width is given to be x, and the area of this rectangular shape plot of land is equal to k. And we are first asked to show that L squared is given by this expression. Then we have to show the length of the fence is a minimum, that is L is a minimum when width is equal to square root k, right? So let's take the height to be as y. Then we can write an expression for area using x and y. So area is what? X times y, or width times height, and we know area is told to be k. So k is equal to x times y, or we can say y is equal to k over x. That is our first equation. Then using this right triangle, we can find a relationship between L, x and y. So using the Pythagoras theorem, L squared is equal to x squared plus y squared. That is our second relationship. Sub 1 into equation 2, and you get what? L squared is equal to x squared plus k over x squared, or x squared plus k squared over x squared, which is what we want to show as part 1. Then we want to find the x value that minimizes capital L. So that is going to be a minimum, local minimum. So we have to differentiate this function we found here. L squared x squared over k squared over x squared. Take the derivative with respect to x. So then 2L times dl over dx is equal to 2x plus, this is same as k squared x minus 2. So minus 2 comes down, k squared x minus 1, or 2L dl dx is equal to 2x minus 2k squared over x. Sorry, this is minus 3, minus 2 minus 1 minus 3. So this will become minus 2k squared over x cube. So we can cancel 2, and what is left? L times dl over dx. Let's take the common denominator. Then x to the 4 minus k squared over x cube. Dl over dx is then equal to x to the 4 minus k squared x cube over L. And L is what? L is square root of x squared plus k squared over x squared, or x to the 4 plus k squared, this one. So we know this is positive and x is also positive. So if we plug in here and shift it, you get this over x cube x to the 4 plus k squared, right? So now we have an expression for the derivative dl over dx. So then let's find the critical numbers of that. So equal this to 0. Only way it can be equal to 0 if it is the numerator is equal to 0. So this gives you x equals 0, but that is not a critical number because x is positive in this question. Then from here x to the 4 is equal to k squared. So x squared is equal to k, or x is equal to square root k. Again, we only need to consider the positive value because x is positive. So x is equal to square root k is our critical number. Let's see if L is a minimum at this point. So we will draw the number line 0 to square root k, and let's find out the derivative sign when x values are between 0 and square root k. So when x values between 0 and square root k, what happens? We can take half square root k. So this will turn into a negative value. So this is negative. When greater than square root k, this becomes positive, the derivative sign. So what is this shape? Decreasing, increasing. So that is a minimum. So conclusion is L is a minimum at x equals square root k. Right. So question 14 is done. So next we will discuss question number 15.